So in this video we're going to look at the 2003 question 3a. In the question we have a particle which is projected from a point on a level horizontal ground. So here's our level horizontal ground, and it's projected at an angle theta to the horizontal. And the question is, find theta if the horizontal range of the particle is 5 times the maximum height reached by the particle. So we're looking for this angle so that the horizontal range, let's call it Sx, the displacement in the x direction, is 5 times as big as Sy. So that means Sx would be equal to 5 times Sy. So it's always a good idea to, when you read the question, see if any equation can be formed from the question. And this is an equation here. The horizontal range is 5 times the maximum horizontal displacement. And sorry, that's max there, I should say. Because later on in the question we're basically going to be using this equation to solve for theta. So let's look at our vertical direction first, our y direction, and let's look at our components. Well, assuming this velocity is u in the y direction is going to be equal to u sine theta. That's our y component. V, we don't know yet. A is going to be equal to minus g. S we don't know, and t we don't know. In the x direction, we know ux equals u cos theta. T we don't know, and Sx we don't know. So let's look at what we're looking for from the equation we wrote earlier on. First of all, we're looking for the maximum displacement in the y direction. So what we're looking at is this distance here, the maximum height of the projectile. So do we know anything about this point? Well, we know right at the top here, the velocity in the y direction equals 0. So now we have an extra variable here. So if we wanted to form an equation from that, we could say that Sy equals ut plus a half at squared. So Sy equals u sine theta t minus, because it's going against gravity, so minus a half g t squared. Now this equation on its own hasn't given us very much, so let's see, can we get rid of a variable here? Well, we know what we could do is we could get an equation for t at Sy, or an expression for t, I should say. So if we use the equation v equals u plus at, we know at the top of its journey, v equals 0, u is u sine theta, minus g times t. And we can say from that t equals u sine theta divided by g. Now there's an expression for t. Now the reason I did that is because if I sub this in place of t in this top equation here, I'm reducing the number of variables that I have in the equation. I no longer have t in there. I have u sine theta g, which I already have in that equation, so I'm reducing the overall number of variables that I have. So let's sub that in there. So we'll move it over here to the left. We have Sy equals u sine theta, and now we're going to multiply it by our expression for t, because remember, this is the time taken to get to the top of its trajectory. U sine theta over g minus a half g, so I'm going to write that as g over 2, and u, or t squared, so that'd be u squared sine squared theta over g squared, because remember, everything in there is squared. That g is going to cancel with that, and we're left with Sy equals u squared sine squared theta over g minus u squared sine squared theta over 2g. So we'll be able to simplify this expression further by adding these fractions, and in order to add these fractions we have to have a common denominator. So we have a 2g here but a g here, so we need a common denominator, so I'm going to multiply above and below this fraction by 2, because remember, if you multiply above and below on a fraction, you're not actually changing the fraction. It's like 4/8 equals to 8/16. I've multiplied above and below by 2, but I haven't actually changed the fraction. It's still the same thing. So now we have 2u squared sine squared theta over 2g minus u squared sine squared theta over 2g, which gives us sy equals 1u squared sine squared theta over 2g. Now that's an expression for the maximum displacement in the y direction, or in other words, the top of its trajectory. If I go back up here, that's our expression for here, between here and here, sy. Now we know Sx is equal to 5 times Sy. So first of all, let's get our next thing we do is get an expression for Sx. Now Sx is this distance here, hang on, where's my pen, is the distance from here to here, it's a maximum range. And these are our variables. And we know that S equals ux times t. Our Sx equals ux times t. So we have an expression for ux, it's u cos theta. But the t we use here has to be the time taken to get from here all the way over to the end here. So it's not the same as the time in our first part of the question. But what we can say is that it's actually twice that time. So if the time taken to get from here to here equals u sine theta over g, which we've just figured out, the time taken to get from here all the way down to here is going to be twice that, 2u sine theta over g. So when we form our equation now, Sx equals ux times t, our ux is going to be our expression for u, which is u cos theta, u in the x direction. And our t is going to be our time 2u sine theta over g. So that's going to give us Sx equals 2u squared cos theta sine theta over g. So there's our expression for Sx. Now remember right at the start I was saying about that equation that we formed right at the start? This is what we're going to use now to finish off this question. We're going to put our expression for Sx equal to 5 times the expression for Sy. And hopefully things will cancel down and allow us to solve for theta. So let's just write that out again there, sorry. So we have Sx equals 5 times Sy. Now Sx is 2u squared cos theta sine theta over g equals 5 times Sy, which is 5u squared sine squared theta over 2g. Now we're going to hope things are going to simplify down here and cancel out, because remember our goal is to find theta. So g's will cancel, u squareds will cancel, that sign will cancel with one of these signs, and we're left with 2 cos theta equals 5 sine theta over 2. Now we have cos theta and sine theta, so we need to reduce that to one trigonometric function, and here we always use tan theta equals sine theta over cos theta. So we're going to rearrange our equation to give us that by dividing both sides by cos theta. So divide this side by cos theta is cancelled, divide this side by cos theta, and we're left with sine theta divided by cos theta here, which equals tan theta. So we're left with 2 equals 5 tan theta over 2. And now all we have to do is, multiply across by 2, both sides. And these 2's cancel. And divide both sides by 5. And these 5's cancel. And we're left with tan theta equals 4, 2 times 2 over 5. So theta equals tan inverse 4 over 5, which equals 38.7 degrees. And that's the answer to your question.